I will be presenting the second homework for this subject. So for the first question, a mixture is 10% ethyl alcohol, 75% ethyl acetate, and 15% acetic acid. Calculate the mass fractions of each compound. What is the average molecular weight of the mixture? And what would be the mass in kilogram of sample containing 25 kilomole of ethyl acetate? So first, we need to set up the basis of calculation or assume that we have a 100 mole of mixture. Okay, so for the mass fractions, we need the grams of each component and then the total gram of the mixture. And for the gram of each component, we can get this by multiplying the number of mole and then the molecular weight. So for the ethyl alcohol, we have 10 mole of ethyl alcohol times the molecular weight, which is the 46.07 grams. And then we gain 460.7, the same as the ethyl acetate, multiply 75 by its molecular weight, which we have 6,608 grams. And then for the acetic acid, 15 mole times its molecular weight, and we get 900.78 grams. And then our gram total is about 7,969.73 gram of mixture. And then plug in plug in on our mass fraction formula, which is grams of each component divided by the total gram of the mixture. And we get for the ethyl alcohol 0.0578 grams ethyl alcohol by gram of mixture. And then for the ethyl acetate, we have 0.8292, and then for the acetic acid, we have 0.1130 gram of acetic acid per gram of mixture. And then for the average molecular weight of the mixture, we have the gram total over the total mole. Our gram total is 7,969.73 grams. And then we assume that our mixture contains 100 mole, and we get 79.7 gram per mole. And then for the mass of a sample of ethyl acetate, we have 25 kilomole of acetic for the sample, and we multiply it by the 100 kilomole of mixture, and then divided by the 75 kilomole of acetic acid from the mixture, and then multiply by the average molecular weight, which we get approximately 2,657 kilogram of mixture. And then for the second question, for letter, first we need to set the basis of calculation and assume that our basis of calculation is gram per minute. And then let's say our system is in steady state, which means that input is equal to output. So for letter A, what is the maximum number of independent material balances that can be written for this process? So since we have 3 known components or 3 known species, then the maximum number of independent material balances that we can have is 3. And then for part B, calculate the m.c, m.e, and m.r using the given mixture, feed rate as a basis, and writing balances in order such that you never have an equation that involves more than one unknown variable. So we assume that our system is in equals to out. So we have the equation 400 gram per minute plus m dot c equals to our output, which is m dot e plus m dot r. So let's start by having a material balance for the excuse me, Ajan. What is this C6H13OH? I forgot. Hexane. No. Okay. So m dot c is equal to m dot e times its output with I mean m dot c equals to its output, which is m dot e times 0.904. And then for the water, we have for input, which is 400 gram per minute times 0.885 grams of water equals to its output, which is m dot r times 0.995, and we get for the m dot r we have 355.78 gram per minute. And then plug in the m dot r to our equation 1. Then we get m dot e equals to 460.94 gram per minute. And then for m dot c, we get 416.69 gram per minute. And then for the part C, calculate the difference between the amount of acetic acid in the feed mixture and that in the 0.5% mixture, and show that it equals the amount that lives in the 0.96 mixture. Okay, so for the feed mixture of acetic acid, sorry, we have 400 grams per minute times 0.115 grams, and we have 46 gram of acetic acid per minute. And then for the output mixture of acetic acid, we have m dot r times 0.005, and we get 1.78 gram of acetic acid per minute. And then its difference is 44.22 grams of acetic acid per minute. And then compare it with the 9.6% mixture. We get m dot e times 0.096, and we get 44.22 grams of acetic acid per minute. Hence, it is equal. That's it, Ajahn. You are muted, Ajahn.
Okay, for the first question that you present is only the conversion, and also you calculate the average molecular weight. That's correct. That we have 3 components. You only convert from the mole to mass, and then you calculate the mass fraction related. And also you use the mass divided by total mole, you get the average molecular weight. Okay, that's correct. And the second question is the basic material balance. We have how many components you calculate? Okay, for this we have 3 components. We have 3 components. We feed hexanol, that's mixed with the acetic acid and water. But for this case, there is no reaction. That means there is no the generation term. There is no the consumption term. That's right. And also we assume like the steady state process, that flow in, flow out equal. That means MC plus 400 equal to ME plus M. That's right. input equal to output for this. Okay, and you can balance either like acidic balance, water balance, or hexanol balance. We have 3 species balance, and also you can balance on total mass balance. We have 4 equations, but we have only 3 independent equations for this case. We can use this to calculate. This is the basic slide. And also for the next homework, I talk to you how to apply this for the multiple process. Okay, thank you for your presentation.